Alrighty, introduction states the Slow and Slothy Seven have officially become groupies and have vowed to follow the band Two Turtles and a Sloth throughout their tour. Next stop, Minneapolis. The total price for this trip is $80 per ticket and $250 for gas. So question number one, how much would it cost if all seven are able to go? Okay, a couple different ways that we can do this, and we should be getting to be pros about this. We know it's $80 per ticket. And we know that we have seven of them going. So we have to take that 80 times the 7, and then we have to add in that 250. Okay, understanding basically we're plugging that into our little function machine, that we're going to take whatever number, we're going to multiply 80 by it, and then whatever pops out of that, we're going to add 250 to. So either way we do this, we have that $560. So we're dropping 7 into our machine. We have $560 for the ticket, plus that $250. So this is going to be kind of a spendy trip, $810. No matter which way we do it, if we want to do it with an expression or with our little function machine, it's going to cost $810. Okay, evaluating an expression is what we just did. Looking at question 2, what if they're not sure how many of them are going? Could you still figure out how much it would cost? And then we would have to explain. So again, we're getting to be pros at this because we've already done this with our introductions. We don't know how many of them are going. So this 7 has become our variable. So the question is, could we figure out how much it would cost? No, we wouldn't be able to. We know that we have that constant $250, but we don't know how much it's going to cost per ticket. So no, we don't know how much tickets will cost. Okay, so basically it didn't tell us to write an expression, but if we did, our expression would have a variable in it. So we wouldn't be able to evaluate it for a numerical value. We could simplify it if we needed to. Okay, I can't write and talk at the same time. So no, we don't know how much the tickets would cost. Okay, the nice thing about this section is it's basically a nice little review of writing equations. We've already done that, but the more practice at this, the better, because everything that you do in algebra is translating from words to symbols or translating from symbols to words. And so we're going to do, again, a little quick review of how to write equations. So go ahead and open up, just need to make sure that that was it. Open up the notes in vocab for this section. Okay, the objective of this section is to write one variable and multivariable linear or algebraic equations to represent context. And the reason why I did put this section in here is because of this big word right here that does change things, equations. We have been dealing with expressions. The difference between equations and expressions is that equations have an equal sign. We haven't seen an equal sign yet. So now we're actually going to put what I call the verb into an expression. An expression is just a noun, the dog. As soon as we put an equal sign in there, now we have a verb, the dog ran. So equations I call sentences in math. The key words that we're looking for are is as much as, is the same as, is identical. All of those type of words are where we're going to put our equal sign, where we're going to put our verb so we can now finally have a complete sentence. So again, we're going to go ahead and translate this, kind of like what we did with the end of the last section. We're going to write it above it, and then we're going to put it all together. So example 1a says we have 7 times the number squared is 5 times the difference of k and m. So let's go ahead and above this translate it into as many symbols as we can. Well, we know 7. We know times is multiplying. A number squared. Now this is where it gets kind of tricky. A number, we don't know what that number is. A lot of times in math, we like to use x. You can use actually whatever variable you want, but x is kind of the default. And we know that that number is squared. So I am going to put a square on there. All right, here's our clue word. There's the is. So we know that that's where we're going to put our equal sign because we are now working with an equation. Is 5 times the difference of, remember there's one of those big ones, difference of we know means we are going to put parentheses around that. We know difference means we are subtracting those two. So it's about as much as we can do with that. Let's go ahead and translate that. We know 7 times x squared. Okay, we don't really need to have that multiplication sign, so I'm just going to smash that 7 and x squared together. So I'm going to put equals 5 times the difference of k minus m. So again, I don't need that multiplication sign. I can go ahead and just put that parenthesis there and say k minus m. So in symbols, 7 times the number squared is 5 times the difference of k and m. All right, let's go ahead and try that on this next one. 15 times a number subtracted from 80 is 25. So we are going to translate that sentence into an equation. Notice again that it's in a sentence because we have a clue word in there, and we'll get to that. So here we go. We have 15 times. Notice that I use a dot instead of x, and this is the reason why. A lot of times that we use that variable x squared. So do please get used to using that dot in there to represent multiplication. Again, times the number. What number are we dealing with? We can be fancy and use y this time if we want to. Whatever variable you want. Again, it does say you assign a variable to it if it's an unknown. We don't know what that number is. So 5 times a number, we are going to subtract that from 80. There's our clue word to see that we're actually dealing with an equation. We have an equal sign now. We have our verb, is 25. Go ahead and put that all together. Notice no parentheses in this because we're just taking 5 times one number. So I have 15 times y minus 80 is 25. And there we go. Go ahead and try the guided practice, and I will put down the correct answers. Okay, 1A brings up a word we haven't seen in a while, which is the quotient. So what I did was I put that division sign there, and then I also put an arrow understanding that I'm going to put that where they say and, because we have a quotient of a number and 8. So that's where I'm going to say x divided by 8. Theirs is the same as, remember, up there that was the clue word to say equal sign. I did put that you could say 2 plus x divided by 8 equals 16, or 2 plus x over 8 equals 16, because we understand quotient, we can actually write that as a fraction. This is the better answer because, again, it's kind of like with the multiplication where we try to stay away from a multiplication sign. Here we try to stay away from division by actually writing it as a fraction, understanding that fractions are actually dividing the numerator and the denominator. And then there's 1b. Again, 27 times k, I didn't put that multiplication sign in there, is 8 squared decreased by 9. Okay, again, just getting used to translation. So here we go, real world example 2. We're supposed to look at this air travel, refer to the information at the left, and how many days will 261,000 flights have occurred in the United States? Well, it says in 1919, Britain and France offered a flight that carried 2 passengers at a time. Now, there are more than 87,000 flights each day in the United States. So, it says, refer to this information, how many days will 261 flights have occurred in the United States? Okay, again, let's go ahead and look at how we're going to write this. We understand that we have 87,000 flights each day. 87,000 flights per day. Well, we don't know how many days there are, so we're going to say per day. We want to figure out when 87,000 flights times that amount of days is going to equal 261,000. We understand that D equals days. Okay, so one way to do it, you can write an equation like this. A lot of kids are going to say, oh, well, I'm just going to take 261,000 and I'm going to divide it by 87,000. Either way is totally fine. It doesn't say to write an expression. You don't have to. So we're going to go ahead and take 261,000 and we're going to divide it by 87,000. And using calculator, That tells us it's going to be about 3 days. So it's going to take us 3 days in order to get 261,000 flights. Okay, so a good way to see that there's probably many different ways to answer this problem. It doesn't say anything about using expressions, variables, so if a kid wants to go ahead and just divide, that's totally fine. Okay, go ahead and look at guided practice number 2, and I will put the answer up. Again, many different ways to answer this. One way to do it is let me go ahead and read it. There are 50 members in the North Carolina Senate. This is 70 fewer than the number in the North Carolina House of Representatives. How many members are in that House of Rep? Okay, so what they're asking is what number minus 70 is going to give us 50? Okay, one way to do it. You can write an equation like that, or kids are going to say, all right, well, I'm going to take 70 and I'm going to add that 50 together, and I know that it's 120, and since this is a story problem, I need to say representatives, or else I get half points off. Okay, so please understand that there are many different ways. There is no right or wrong way to get the answer. Okay, looking at this next part, it says a rule for the relationship between certain quantities is called a formula. These equations use variables to represent numbers and form general rules. A lot of times we see that in geometry. All right, and that's actually what we're going to see in this one. We're supposed to translate the sentence into a formula. The area of a triangle equals the product of 1/2 the length of the base and the height. Okay, there's a lot of unknowns in this problem. The area of a triangle, well, we don't know the area of a triangle. So instead of putting the area of a triangle, I'm going to put A. That represents the area of a triangle. Well, here's the word equals right here. So I'm going to put an equal sign there. The product of, I understand product means I'm multiplying 1/2 the length of the base. Well, I don't know how long the base is, so I'm going to call him B. And the height. And I don't know what the height is, so I'm going to call him H. And I understand that's the product. So I'm going to take 1/2 and I'm going to multiply it by B and by H. So understanding that that multiplication sign goes right here. So I understand that the area is 1/2 times the base, so I'm not going to use the multiplication sign, times the height. Okay. Another way that you could do this is you could put the base times the height in the numerator and take that and divide it by 2. Okay, so again, that is the formula that you would see in a geometry class. All right, go ahead and try guided practice 3. Okay, a pretty wordy formula here, but it says in a right triangle, the square of the measure of the hypotenuse C is equal to the sum of the squares of the measures of the legs A and B. Okay, again, there's a lot of words in there, but I see this square. I see the measure of the hypotenuse, but they actually give me a variable there. So I know that I'm going to take that C and I'm going to square it. I see it is equal to, so there's an equal sign. Sum of, I understand that when I see that and, that means I'm going to add them. Again, the squares. So a lot of things going on in this problem. I would recommend reading it one time. Then I would recommend just kind of breaking it into chunks and putting symbols in each one of those pieces of the chunks. Okay, looking at this next one, now we're going to go backwards. They actually give us an equation. We have to translate it into a sentence. So here we have many different ways to do this. We can look at this as 6z, so we know that we're multiplying there, and then we are subtracting 15. We have an equal sign, so we could say is, and then we have 45. So I'm going to write this as 6 times z minus 15 is 45. So a lot of times this is a little bit easier than translating the other way. Many different ways to do this. Some kids like to say 6 times a number. You could do that, okay? Or the difference of 6 times a number and 15. Many different ways to do it, okay? Looking at B, again, we could say that this is y squared. We could say the square of a number. I'm going to be fancy and say that. The square of a number. And the sum of, or I'm sorry, let's just say the square of a number plus the product of 3 and x, because we understand the product means that we are multiplying that 3 and x. I'm going to say is equal to w. Don't say is equal to a number, because we've already said that. You could say is equal to another number, and that would be fine. Again, many different ways that we could translate that. Go ahead and try those guided practices. Okay, one way that you could rewrite 4a is 15 is the same as 25 times a number squared plus 2. The way that you could translate 4b is the difference of, because we're subtracting, 3 halves of a number, and the cube of t, because we are taking it to the power of 3, is 132. All right, one last little example here. This is one of my favorites because this is when the students become the teacher. It says we're actually supposed to write a problem based off of this. So in the situation, t is the time that Maxine drove in each turn. T plus 4 is the time that Tia drove in each turn, for each turn. And we are supposed to look at this. It says 2t plus t plus 4 equals 28. And again, the student turns into the teacher. This, I always tell them that this is what you want your students to write. So how are we going to write this? Well, we have 2t here, and we know that t is the time that Maxine drove in each turn. So it looks like she drove twice. Looks like Tia only drove once. Well, we are adding them together, so it looks like all of that time equals 28. 28 minutes, probably. Okay, so we're going to say that Maxine drove twice and Tia drove once. Okay. Together, we could say that they drove for 28 hours or 28 minutes. It doesn't actually say. Together they drove for 28 minutes. Okay, we could go on and say, how long did Maxine drive? For how long did Maxine drive? I really like these type of problems because it makes students think deeply about what all of this means. If T means the time that Maxine drove, okay, Tia looks like she drove 4 minutes longer. So we could have actually wrote that in here. Maxine drove twice and Tia drove once. Together they drove for 28 minutes. And maybe I would recommend that you put that in there. Tia drove once, but drove 4 minutes. I spelled minutes wrong. Goodness gracious. 4 minutes longer than Tia, than Maxine. Okay, probably a better way to write that because then they understand that we have a T plus 4 because that was longer. Okay, anything like that, I'm going to give myself a C- on my problem here. Okay, but again, have the students look at that and translate it and understand what this 2t plus this t plus 4 means. All right, let's see if I can do a better job on this guided practice. Go ahead and try it and I will put up the answer. Okay, a much better way to go about this. Understanding that we have P equals best salary. This 0.1p equals her bonus. Well, 0.1 represents 10% of whatever P is. Well, that's salary. So I wrote that. I wrote that 0.1P represents 10% of her salary. Then let's actually look at the equation. We have her salary. We added in her bonus. And those two together equal 525, which must mean her paycheck or how much she got paid. So we have her salary and her bonus together gives her a $525 paycheck. Well, again, as a teacher, you want to give them this information so they can write that in their problem. So we say that Beth gets paid a salary, and means we're adding a 10% bonus. It says if her paycheck was $525, how much is her salary? So again, they didn't actually go and solve this problem, but we do have an equation that could represent this. Okay, so again, go ahead and look at all of the different pieces, translate that into what it means, and then decide what kind of equation would work for this. So again, this section, a good review of how to translate from algebra into sentences. The other way around, understanding the difference between equations and expressions. Equations have that equal sign, has the word is in there, that you could actually go and find an answer. We're turning on that function machine. All right, you are ready for the assignment.